Yes, the session is being recorded. Now let us start. Day 3. Day 3. See, day 1. See, about day 1 class. Yes, 7:30 p.m. Day 1 class. About course introduction discussed. About me, about your course, and all the course introduction and syllabus and all that discussed. That is day 1. Day 2. Java introduction. About what is Java. Yes, about JDK. JDK different versions discussed. JDK, that initial features and different versions and like different editions. About different editions discussed. Yes, all that editions discussed here. Different editions. Next, what's a framework? About framework discussed. So this is completely Java introduction. Java introduction yesterday discussed. Today, let us start with Java features. Java features. See, JDK 1.0 released with below features. JDK 1.0 released with these features like independent of platform, portability, OOP language, scalability and security. Independent of platform, portability, OOP language, scalability and security. These are the initial features of Java. See, these features may not be understanding directly. Just before going to these features, there are some basics. There are some basics like yes, about operating system. Yes, what is operating system? Yes, you should know about OS. What is OS? How it's working? Okay. Yes, about OS. So next about interpreter. So what is interpreter? Okay, next and compiler. So about compiler. Next about exe file and dot class file. Dot class file. Okay, dot class file about exe file dot class file. Next about low level languages and high level languages. Low level, high level languages. So these are some basics. So these are some basics here. Okay. See, today topic is about yes features. So yesterday discussed about Java overview. Yes, Java overview discussed yesterday. Complete Java discussed. Java contents discussed. Okay. So first version of Java is released with these features. So today topic is about these features. Today topic JDK 1.0 released with below features like independent of platform, portability, OOP language, scalability, security. Yes, about these features. Let us see about these features. Yes, about these features. Okay, about these features. So day 3. Yes, about all that features here. 1 second. Yes. So JDK 1.0 released with below features. Yes, independent of platform, portability, OOP language, scalability, and security. Today we should discuss about these features. So yesterday completely Java overview discussed. Yes, first version of Java released with these features here. See, to understand these features, yes, we need some basics. Yes, you guys should know about some basics about Java, basics about software basics. So before going to these things here, first let us see about these basics. So I'm starting from the basics. See, starting from basics. Yes, starting from basics. Yes, non-IT background guys, everyone can understand. I'm starting from very scratch. Yes, I think this may not be expected. Very scratch. Who don't have the IT background also can understand. Who don't have IT background also can understand here. Very basics. Okay. See, computer aware. Computer aware. Basically two categories. First one, hardware. Second one, software, hardware and software. Yes, hardware. Yes, these are physical components of a computer. Hardware, physical components like keyboard, mouse, monitor, hard disk, yes, screen, motherboard, RAM, and all this keyboard, screen, mouse, hard disk, RAM memory, motherboard, all the hardware components, but not necessary for us. We are not a hardware engineers, so we are the software. So we are the software engineers. Let us start the software. What is a software? What is hardware? Software here. See, started from very basics. Here the thing is here. My intention is yes, I should make you perfect in every area, including fundamentals. Including fundamentals. So what is software? See, in software, everything is a program. Everything, everything is a everything is a program. Everything is a program. Yes. It is a collection of programs. It's a collection. It's a collection. It's a collection of programs. It's a collection of programs. In software, everything is a program. In software, everything is a program. It is a collection of programs. It's a collection of programs like C, C++, Java, Python, all comes from software. It's a collection of programs. See here, software basically two categories. Software basically two categories. First one, system software. Second one, application software. System software, next application software. System software and application software. Yes, what is system software? System software. Yeah, this is to interact. Yes, this is to interact interact with hardware components. This is to interact with hardware components. System software, this is to interact with hardware components. System software to interact with hardware components. Yes, example, system software example. Yes, operating systems and device drivers. So this comes under system software. Yeah, system software. Yeah, this is to interact with hardware components. System software is to interact with hardware components. Examples, operating systems and device drivers. Yes, what is application software? Application software. See, this is for the purpose of application development. The application software for the purpose of application development. Application development. For the purpose of application development. Yes, applications, apps. Yes, in our daily life we are using many applications, right? That kind of applications. Yes, yesterday we discussed the same point. In our daily life, many applications like WhatsApp. Yes, WhatsApp, which is mostly used application in our life, daily life. Okay, Facebook. Okay, next Twitter. Next Insta. Yes, Flipkart. Like this, Flipkart. Okay, next. Yes, online trading application. Online trading apps. Okay, like this, online trading applications. Like this, many applications, right? Yes, banking applications, stock exchange applications. Yes, Google Pay, Phone Pay, GoToMeeting, GoToTraining, Zoom. Like this, many applications. See, to develop this kind of applications, we need some software. Yes, to develop this kind of like Facebook, WhatsApp, Twitter, they are that internet-based applications, right? To develop all these kind of applications, we need some software. That software is application software. Yes, application software. Yes, for the purpose of application development. Examples, applications. Okay. Yes, application software. Best example, Java. Java is a mostly used application software. Java is a mostly used applications of Java. Next, C and the C++ also application softwares. Next, .NET also application software. Next, Python also application software. Okay. Next, Hadoop also application software. Next, databases also application softwares. These are examples of application softwares. Examples. Okay, they are application softwares. Application softwares. See, in software, we are using many technologies, right? More than 100 technologies we are using, more than 100. Like some languages, we are using some languages, using some language, we are using some languages. Sometimes we are using some tools, sometimes using packages, languages and tools and packages. Various kinds of things we are using, right? Languages and tools and packages. So various things we are using, various things. Okay, language like Java, C, C++, Python, the language, right? Tools like data warehousing tools, reporting tools, next big data tools, next testing tools, next AWS tools, DevOps tools, like this, many tools we are using. Next, packages like ERP package, like SAP ERP, Oracle ERP, MS Office, Tally ERP, some packages, right? Many things we are using. So exactly which is application software? See, many things we are using in software, many things. So exactly which is application software? Exactly which is application software? See, here system software. This is to interact with hardware component. This is to interact with hardware components. System software interacting with hardware components. Okay. See, only OS can interact with hardware components. Others cannot. See, application software cannot interact with hardware. Okay. Yes. System software. Yes, software which is interacting with hardware, system software. Which is not interacting is application software. See, only OS can interact with hardware components. See, device drivers, see this. Device drivers, they are part of OS only. Device drivers is a part of OS. Device drivers are part of OS. Okay. See, only operating system can interact with hardware components. That means except OS. Except operations, other application softwares. See, except operating systems, all are application softwares, all are application softwares, all are application softwares, except operating systems. Yes, operating systems. Can you tell me some case operating systems? What are the operating systems using here? Except operating systems, all are application softwares. What are the operating systems we are using? Operating systems we are using Windows. Okay, fine. Windows. Next. Come on, guys. You can ping in chat box. Yeah, Linux. Good. Linux. Next, anyways, Unix. Okay. Next, anyways, Mac. Next, iOS. Okay. Okay. Next, Mac OS. Okay. Next, Solaris. Yes, almost this outdated. Solaris not in here. IBM AIX. They are old operations. IBM X. Next, HP Unix. Like this, these are different operations. So except this, all are application softwares. Except this, all are application softwares. 1 second. Get this today's class notes. See, document page 1, first page. Yeah, today started from the scratch, from the beginning started. See, last 2 classes, nothing discussed. Last 2 classes, all the introductions. Last two classes only introductions discussed. Last two classes just introductions. So today class, yes, I started from the scratch. Okay. See, software. Yes, software is a collection of programs. Software basically two categories: system software, next application software. See, you guys, running notes is not necessary. Running notes not necessary. Yes, I have prepared very clearly. Very clearly prepared. See this, see the document here. Today topic, today topic. About today topic. See, system software, software basically two categories: system software, next application software. See, about system software, it interacts with the hardware components. Example, device drivers and operating systems. Application software for the purpose of application development. Examples, yes, except operating systems, other application software. Same points mentioned in the document here. Same thing as this. Every point it's there in document. Just you can follow document. Just to follow the document here. Okay. Yes, now topic is about ways. Yes, now let us start with ways here. See, in system software ways. Let us see about ways. Once ways topic completed, next move to application software. Let us see about ways. Yes, about ways. Yes, about ways. Yes, some question for you guys. Some question. Some question. Can we run any program? Any program without operating system? Yes, can we run any program without OS? Can we run any program without operating system? Can we run any program without OS? Without OS running programs. Without OS running programs. Without OS running programs. No. No OS, no computer. No OS, no computer. No OS, no computer. Without OS, no computer. If no computer, how can you run the programs? We cannot have. OS required compulsory. Okay. See, except bias, except bias to run all programs OS required. To run all programs OS required. OS required. Except bias. Except bias to run all programs OS required. Except bias. Except bias to run all programs OS required. What is bias? What is bias? Bias stands for what? Anyone guess? What's a bias? Bias stands for what? What is bias? Yes, okay, good. Many answers. Yeah. Bias stands for this basic input and output system. Basic input output system. Yes, bias means it's a basic input output system. Yes, bias. So what is exactly bias? Bias is a hardware. Bias is a hardware program. It's a hardware program. BIOS is a hardware program. Yes, it is a chip level. It's a chip level BIOS chip level program. Yes, BIOS chip in system. This is a BIOS chip. Let me show that BIOS chip. Bias image. See that it's a bias. This is bias. This is bias. Here it's a bias. It's a bias chip. Okay, that bias chip can is bias program. Bias program. Yes, what's the task of bias? See bias. Bias is responsible to boot operating system. Bias is responsible to boot operating system. Yes, what is booting? Yes, what is booting? Booting is a process. Booting is a process of loading. Loading OS hard disk to RAM memory. Hard disk to RAM memory. RAM memory. Hard disk to RAM memory. Hard disk to RAM memory. Booting is a process. Booting is a process of loading OS from hard disk to RAM memory. See, when you power on your system, you guys, when you power on your system here, first of all, power goes to BIOS chip. This BIOS chip. Then BIOS program starts. BIOS program starts. After starting it, you load OS from hard disk to RAM memory. See, OS in the hard disk, see, where is OS in C drive? In C drive, Windows OS, right? See this. In C drive, this is a Windows OS. Here OS is there. This is in the hard disk. It's in the hard disk. That BIOS program takes OS from the hard disk, loads into RAM memory. So this is BIOS is a first program. In your system, BIOS is a first program. It's a hardware level program. Once you power on your system, once you power on system here, first of all, power goes to BIOS chip. Then BIOS program starts. The BIOS program loads OS from hard disk to RAM memory. It's nothing but booting process. The BIOS is responsible to boot operating system. BIOS is responsible to boot OS. Okay. So once booting is done, your system is ready. Yes, this OS system is ready. Yes, where this OS is running? This OS is running in RAM memory. Here OS. OS running in the RAM memory. Is running in the currently OS running in the RAM memory. Now this OS is responsible. This OS is responsible to take your request. Now let us say about OS. Now topic is about OS. Yes, what is operating system? See, what is operating system? About operating system? What is operating system? What is operating system? About OS. About OS. Okay. See, yes, computer. In computer, different layers in computer. So first, hardware layer. Hardware layer. On top of hardware layer, there is a operating system. Operating system. On top of hardware, there is a OS. On top of hardware, there is a OS. See, on top of OS, all programs running like C program, yes, C++, Java program, yes, maybe Python script, all are running on top of OS. Next, Hadoop, next from databases, all are running on top of OS. All are running on top of OS. Okay, yes, all are running, yes, right. Salisiram, good. Yes, all are running on top of OS. See hardware. On top of hardware, there is a OS. On top of OS, all these programs running. All these programs running. Yet these are application softwares, right? All their application softwares. All their application softwares. All these are application softwares. All are application softwares. So these all are application softwares. Okay. All are application softwares. All are application softwares. One second, let me have some more. Yes. See, all these are application softwares. See, except OS, all are application softwares, right? Except OS. See, OS, only OS can interact with hardware. OS on top of hardware, OS is running. On top of hardware, OS is running. So OS is interacting with the hardware. On top of OS, all the programs running. The application softwares like languages, packages, tools. Every software, all the software has to run on OS. Okay, these application software cannot interact with the hardware directly. Yes, there is OS required. Only OS interact with the hardware. So OS is a system software. OS is system software. Reason interacting with the hardware. OS interacting with hardware is a system software. Application software running on top of OS. So on top of OS, all programs running. On top of operating system, all programs running. So OS, it's acting like a platform. Yes, OS giving platform. OS giving platform. On top of it all are running. OS giving platform. On top of it all are running. So OS acting like a platform. Yes, here OS acting like a platform. So what is OS? What is OS? Yes, it is a platform. It's a platform. It's a platform. It's a platform. Yes, where we can run all application softwares. All application softwares. All application softwares. Where we can run all application softwares. Okay. So what is OS? It's a platform. OS is a platform. Yes, where we can run all the application software. Yes, acting like a platform. So OS acting like a platform. On top of it all are running. So OS it's a platform. OS is a platform. See, Java is independent of platform, right? Java is independent of platform. That means platform means OS. Platform means here it's a OS. Java is independent of platform. That means Java program running on any OS. Independent on any OS Java program running. How Java program is made as independent of platform? The topic next we'll discuss. How Java program made as independent of platform? It's a tomorrow topic. Yes, about these features tomorrow. Today all the basics. Today all the basics. Okay. So what is OS means? It's a platform. It's a platform where we can run all the application software. Okay, fine. Not only platform here. Suppose for example, C program generating some output. Output of C program first of all delivered to OS. Output of C program first of all delivered to OS and then transferred to output device. Similarly, Java program also. Yes, maybe C program or C++ Java, all the application softwares. These programs generating some output. So first of all, this output simply goes to OS and then as a transfer to output device. So for reading data from the keyboard, input keyboard to OS, OS to these programs. So between application software layer and hardware, there is a OS. Okay, OS. So between application software and hardware, there is a OS. Means it's interacting like a mediator, between application software, hardware components. Simply you can say the interface. Is interface means between two things. Interface between application software and hardware components. So it is an interface. It is an interface. It's an interface between application software layer and this hardware components Okay, yes, 1 second. Yes, Tulsi Ram, kernel, it's a part of OS. Kernel is one layer in OS. Okay, kernel is a one layer in OS. That kernel contains device drivers and libraries. Instead of the kernel, there is a device driver. Yes, in OS again 2 layers. In OS there is a kernel layer. That kernel layer contains device drivers and libraries. Of course, that is not necessary for us. About kernel, not necessary here. Kernel contains device drivers and libraries. That is not necessary for us. That is very low level about OS. Okay. Yes. Now, next in OS In OS there is a library. Yes, in OS there is, in every OS there is library. That library contains input-output functions. That library contains input-output functions. Library contains input-output functions. Yes, input-output functions. Functions means C language functions. Functions means C language functions. Means library is a collection of C language functions to perform IO operations. Library is to perform IO operations between application software and hardware. See OS, inside of OS, this library. Yes, this library is a part of kernel. Listen, Ram, you're saying about kernel, right? This library is a part of kernel. Yes, about kernel, not necessary for us. Leave it. In OS, there is a library. This library contains all C language functions. C language functions. Reason: every OS developed in C language. Linux in C language, Windows in C language, Unix in C language, Mac OS in C language. Every OS developed in C language only here. So these are C language functions. Yes, this is a library. In OS, there is a library here. So with the help of this library, OS can communicate between application software and hardware components. Yes, OS communicating between application software and hardware for this purpose using library. Okay, see, every OS has its own library. Every OS has its own library to communicate between application software layer and hardware components. Yes, so OS using library. Yes, inside of OS is library. With the help of library only, it can communicate between application software and hardware components. So every OS has its own library to communicate between application software and hardware components. Yeah, this is important point. In Java perspective, important point. Okay, Java perspective, it's important point we'll discuss. Wait. Okay. Yes. Next. One more thing here. One more important point. Java perspective. One more important point. See, C program or Java, Python, these programs, right? Application software programs. So these programs, first of all, what happens here? First of all, these programs, links with OS library. After linking, then communicates with the hardware components. Yes, it has to link. First of all, all the programs, first of all, linking with OS library. After program execution starts, before running, it has to link. Every program, first of all, linking with OS library. Then program starts. Program starts execution. So before going to start, first of all, linking. Okay, so every program, yes, has to link with OS library. Yes, before going to run. Yes, first linking with OS library, then running program. Yeah, this is a very important point. Fourth point. Yes, in Java features, this topic will be repeating. Java features. How is Java program linking with OS library? How is Java program linking with OS library? The topic getting. Okay. C program linking with OS library. C program, C++ linking with OS library. Java and Python also linking with OS library. Those are some static linking, dynamic linking. C and C++ statically linking with OS library. Java and Python is dynamically linking. Static linking, dynamic linking, next topic. This is not a right time to discuss. This is not a right time to discuss about statically, dynamically. The topic tomorrow. Tomorrow we'll discuss. Okay. Yes, linking will be done now. Okay. Tulsiram. Suppose if it is C and C++ at the time of creation of exe file itself, linker will link it, or compile. C language compile link it here. Yes, in C language compile there is a linker. There is a linker. That linker linking. Okay, in C and C++, at the time of creation of exe file itself, linking with OS library. That topic is very interesting topic. That is. Very interesting topic. The topic tomorrow getting. Suppose if it is Java program linking with OS library by the JVM. Java program by the JVM. JVM linking Java program with library by the JVM. Okay. Python interpreter links with OS library here. That link topic tomorrow we'll discuss. Static linking, dynamic linking. Very interesting topic that is. Tomorrow we'll discuss. Okay. Yes. So this is about OS. Just introduction about OS. Okay. So what is OS means is a platform. Next is an interface. Okay. So every program has to link with OS library before going to run. So this is about OS. Yes, enough. This topic is enough to understand Java features. See, to understand independent of platform, whatever, to understand these features, the OS topic is enough. That topic is enough here. Enough. Now, see. So this is OS. About OS, that nodes. Can we run any program without OS? No here. Can we run any program without OS? No. Same that program, same what we discussed in the class. Same it's in document, our class document. Same. This is for you only. I'll be sharing with you. Same as these points are there. What is operating system? Yes, about OS. That all the 4 points here. Next, that OS layers, right? Okay. See, running nodes is not necessary. So what are things I'm explaining here? Topics explaining here. As this you can see in document. See, my class explanation and document same order. Class explanation, document same order. So don't worry about notes. Don't worry. Just you follow documents. Okay. So this is about OS. Fine. Yes. Software, system software, application software. System software about OS discussed. Now, what is Java? Java is application software, right? Java is application software. Java is application software. Java is application software. Now let us move to application software. Our topic is now application software. Application software. Topic is about application software. See, application software, two categories: front end and back end. Front end, back end. So application software, two categories: front end and back end. What is front end? What is back end? Let us say about front end. What is a front end? See, front end. Where is that? Front end. Yeah. See this. It's a form, right? Registration form. Registration of first name, last name, email address, phone number, right? Registration form. Just we are filling all the details, right? We are filling all the details and submitting. Yeah, this is called as front end. That user interface. It's a user interface. It's a front end. Front end. So this front end taking data from us. Yeah, this is called a front end. It takes data from us. It will take data from users. After taking this data storing somewhere. That is called a backend. So front end is to collect the data from users. Front end interacting with users and collecting data. Next, storing into some location. That location is called as backend. Backend is to store the data. Okay. See, your registration details, right? Call student details, filling, submitted. Your data storing somewhere. Yes, Durgasoft online team. They will take the data, then they will do the follow-up, right? That's it. Yes, all the data storing some location. This data, your data storing at some location. Your data storing at some location. That location is called as backend. Backend is to store the data. Front end is to collecting data here. Front end collecting data. See here, front end. These are to interact with users. It collects data from users, end users, and stores in the backend. So front end is to collect data from users, collecting data from users. Backend is to store and maintain data. Storing data like databases. Like databases like Oracle database, MySQL database. So all databases. Next, files like Windows file system, Linux file system. Files also storing data. In files also we can store data. In database server storing data. Next, HDFS. HDFS means Hadoop distributed file system. HDFS is a Hadoop distributed file system. Hadoop distributed file system to store and manage big data. For big data purpose, HDFS. Okay. Yes. So these are, yeah. So we call it backends here. All the backends. Backends are storing data. Backends are storing data. Front end is interacting with users and collecting data. Okay. See, now behind of this form is a JSP form. Java JSP form. Behind of this form, Java program running. Behind of this form, JSP Java server pages, Java program running. The Java program taking data from you with the help of form here. See, Java program using form to take data from you. So Java program taking data from you and storing the database. So Java program interacting with users, right? So it's a front end. Java program is a front end. So front end comes on the front end, is a front end. So Java is a front end. Okay, now let us move to front end. Java is a front end. Yes, in front end, language and packages. Languages and packages. See, package is a ready-made one, ready to use. Package is ready-made one, ready to use here. Like MS Office, a package. No coding. Yes, package. Don't have any program. Don't have programming. Packages. Package don't have programming. Okay, directly using package like MS Office, ERP package, Tally accounting, and all that package directly using. Languages, yes, we should write the coding. We should write the coding. So Java is a language. Java is language. Now let us move to languages. Topic is about language. See how I'm introducing into Java. Way of introduction. Right, also very clean and clearly explaining, right? Introduction. Start with software. Software, system software, application software. Java is application software. So moving to application software. Yes, moved here. Yes, this front end, back end. Java is a front end. So moving to front end. In front end, language and package. So Java is a language. Now moving to languages. Yes, let us say about languages. Yes, about languages. Yes. The languages. What is language? What is a language? What is a language? It's a media of communication, right? Language is a media of communication between two persons or two animals or two trees. Every living thing has its own language, communication purpose. Communication purpose. Yes. Now come to software languages. Yes, our topic is about software languages. Yes, in software languages, first one, yes, computer understandable language. Computer understandable language. Computer understandable language. Okay, see, computer understanding some language. Next, we are understanding some other language here. User understandable. Ours user understandable. User understandable. User understandable language. Computer understandable, user understandable. See, user understandable languages. User understandable. User understandable language like English language. So, for example, C program. User understandable language. C program. C program. Yes, looking like English language. So this is user understandable language. Java program. Like English language. Java program. Java program. So but this is some Java program. Yes, English, looking like English. So these are user understandable languages. What is computer understandable language? You guys, what is computer understandable language? Computer understandable language. What is computer understandable language? What is computer understandable language? You see, it depends on generation of computers. Generation of computers. Yeah. Chandrika 01. Okay, 0s1's binary format. Okay, good. 0s1's binary format. It generation, yes, it depends on generation of computers. Here some question for you guys. Some question. How many generation of computers? Anyone can you answer this? Very simple question. How many generation of computers? Yes, these all are some basics. So they are unknown facts. Even who is having 10 years of experience also they don't know about it. Even 10 years of experience also they don't know about these basics. How many generations? 5 generations. You say 5. 5 generations. First generation. Yes, what is first generation computer? Shashank Reddy. Yes, what is first generation computer? First generation. Yes, it's a first generation. 1 second. Yes, vacuum tubes based. First generation, very old first computer. Yes, vacuum tubes based. Vacuum tubes. Second generation. Transistor based. Solution. Yes, all these electronic subject. Yes, we have this subject in our engineering. Yes, we have one electronic subject. In that we have all of this. Vacuum tubes based here, transistor based here. Next IC based. Yes, fourth generation. Anyone idea? Fourth generation. Processor based. Means a present. This is present generation. Now we are at, yes, fourth generation. We are using the fourth generation computers. Fourth gen. Yes, what is fifth gen computer? Yes, means feature. Now presently processor based. Feature. Yes, good. AI based. It's AI based computer. In feature, it's AI based. Feature is AI based. See, presently processor based. See, processor based understandable language. Processor based understandable language is binary codes. It's a binary codes. Yes, binary code means like 0s1 format. It's a binary code. Okay. Yes, next A based understandable language. See, A based computers. A based understandable language is English. It can understand English. When he's saying something, yes, that can understand our English. Okay. See, suppose you're a home. A based computer, automized home with A based computer. Your home automized with AI computers. Yes, you can control the entire home. Door opening, door closing automatically. Yes, saying some words, some keywords for door, some keyword. Okay, open door, power off, on. Okay, washing machine, on, off. Simply say something. Yes, automized home. Yes, everything is automized. So once your home automized here, our things becomes easy. Sitting one place, you can control everything. That is automated home. Okay, suppose car, automated car. Yes, AI based computer. Yes, car working with AI based computer. Yes, we can control the car. Yes, start and stop car. Engine on, engine off. Okay. Next starting and speed control and all this controlling automatically here. You're saying some words, about opening door. Yes, if you say some word, door opens automatically. Suppose, for example, sunroof car. You want opening that roof, that will be opened. Opening, yes, some dicky opening, yes, automatically here. If you say something here, everything happens here. Next, one more thing, you can control the car from your home also. Okay, suppose your car given to driver. Yes, driver, what is doing? Yes, we can see, we can observe what is doing, is what, in which direction is going, what is he doing presently. Everything can control. Yes, something like Alexa. Something is like Alexa. Yes, right. Something like Alexa. Okay, that is AI based computer. Yes, AI based. Yes, maybe 2025. 2025 starting AI based computers. Yes, to reach the entire world. Yes, maybe taking for another 5 to 6 years. Maybe 2030 or 32 years. Reaching the entire world. So by 2035, everything is AI based. Okay. By 2035, what happens here? By 2035, computer becomes intelligent than a human being. Computer will be most intelligent than human. In 2035, what happens here? Computer becomes most intelligent than human in future. That's it. Okay. Yes. See, everything is automated. Everything is automated. Suppose your car is automated. Without driver, car going. Without driver. Suppose some route defined, in that route that car will go. Suppose in opposite direction, any car comes, maybe stopping immediately or taking another direction automatically. Driverless car, no accidents. Okay, suppose driver is there. Yes, he will drive on his own right, own way. But AI based computer, yes, AI based car, yes, in different path only going here, following some rules. All the following rules here, it will follow rules here. No chance of accidents. Okay, no chance of traffic blocking. Okay, everything systematic. Everything will be going in systematic. That is automated. Okay, yes, we are expecting. Okay, yes, within 10 years, world may happen 20 by 2035, expecting like that. Yes, we are hoping for that. Okay, yeah, that is AI based. Okay, right? Yeah. So present generation processor based. Processor based understandable language binary code. Binary code. This binary code is called as, yes, it's a low level language. System understandable low level language. Yes, user understandable high level language. So a software languages are basically two categories. Low level languages, low level languages. Next high level languages, low level and high level. Low level languages and high level languages. Low level and high level languages. Low level and high level. Okay. Yes, low level language. Yes, it's a system understandable language. Yes, it is a yes, it is a system. And yeah, yes, Chandrika, Tesla has developed a car, Tesla car. That's good. An example. Yes, it's a system understandable language. System understandable language. System understandable language. Okay. Low level language. It's a system understandable language. Yes, it's a system understandable language. System means, yes, system means it's a processor. System means processor. It's a processor. It's a processor. It's a processor understandable language. Yes, it is. See, it is in the form of, binary code. It is in the form of binary code. Like zeros ones, like binary code. This is binary code. Binary code. It is in the form of binary code. Binary code. Yes, what is exactly this binary code? How this binary code generating, we'll discuss. Once started Java programming, started, that time I'll explain about that binary code. How binary code generating, how that binary code generating, we'll discuss. In Java programming, I'll explain very clearly. Okay, yes. It is called as machine language. See, it is called as machine language. 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 Okay, low level language. Next, high level languages. high level language, high level language, high level language, high level language. Yes, it is a user understandable language. Okay, it's a user understandable language. Yes, it is like a, it's like a English language. It's like English language. Example, Java. Java is a high level language. Java is a high level language. Okay, Python is a high level language. Okay, yes, C and C++ is a high level language. Okay, yes, like some HTML is a high level language, HTML coding. Okay, HTML, JavaScript. Okay, next Scala, all the high level language. Here one more question for you guys. One more question. Which is first developed high level language? Yes, anyone idea? Which is first developed high level language? No, Unix is a OS, is not a language. DOS is a first, okay. Now, okay, fine. DOS is first software, first OS. DOS is a first OS. Okay. DOS, 1 second. That is the software history is there. One day I will explain about software history. Yes, in Java, once entering this Java, we'll discuss about software history. That software history. DOS 1945. First OS, DOS. What is first high level language? Yes, topic is about first high level language. Which is first high level language? C language, 1970. DOS is OS. C language, after Unix base. Next C++. Python. Yes, that history, software history. One day I will explain about software history. See, since 1993, I know what was happened in software field. See, before 93, nothing. So 93, I'm in software field. Started my engineering in 93. So I know the software, about software since 1993. Before that, nothing. Just C is there, Unix is there, C++ is there, and Python. Before that, before 90s, nothing. 90s period started software. 90s period when software started. Okay. Yes, C language. Yes. For this answer, C language. Yes, C language. C language is a first developed high level language. By whom? Anyone idea? C language is a first developed high level language by whom? Yes, good. Tulsiram, good. Yes, Dennis Ritchie at 80 Anti Bell Labs, USA in the year 1972. The year 1972. Okay. Java 1975. Sorry, 1995. C language 72. Yes, almost 25 years difference. C and Java. Java 1995. That is your before your birth, right? Java before your birth. C language before my birth. Java before your birth. C language before my birth. Okay, so C and Java, this is a 25 years gap. Okay, right? Yes. So here C language is first developed language, first developed high level language. At AT&T Bell Labs, USA 1972. Okay. So here, yes, user understandable high level language. Yes, like C, Java, Python, these high level language. This high level language program, yes, high level language to binary code. Every program has to convert into binary code. System understandable language. Suppose C program. Suppose this is Java program. This program is a high level language. This code has to convert into binary codes. Java program, high level language. This code has to convert into binary codes. Okay. C program, Python, all the high level language to binary code means system understandable language. High level language to binary code. Yes, who will convert it here? Which one will convert from high level language to binary code? Yeah. Tulsiram, right, good. Yes, interpreter, either interpreter or compiler, converts from high level language to binary code. Either a compiler or interpreter convert from high level language to binary code. That's it. Okay. Yes, compiler, interpreter. See this today topic. Everything is there in document here. Just you guys follow document. Running notes is not necessary. Yes, everything very clearly explained here. Like front end, back end, language packages, low level language, high level language, software languages. Okay. The generation of computers, even that also prepared in document. Okay, processor based, AI based English language. Okay. Yes, low level language, high level languages. Yes, about low level language explained clearly here. About high level language. Same. C language, first high level language examples. High level language to binary code. Yes, this is by interpreter or compiler convert from high level language to binary code. Till now, what are the topic discussed? Everything is in document here. See, next topic is about interpreter and compiler. What is interpreter? What is compiler? How it's working? Difference between interpreter versus compiler. Next, Java. Yes, is it compiler based or interpreter based? About Java introduction. So tomorrow, starting Java introduction. How Java is working? Yes, is it compiler working or interpreter working or something working? How JVM working and all that topic tomorrow discuss. So tomorrow topic interpreter, compiler. Next Java introduction. Yeah. So this is, yes, from the beginning started. I think no one expected this much of scratch. Yes, I'm sure no one expected this much of scratch. From the very scratch started. Okay. Yes, here my intention is you must have every knowledge in the software field. That's the reason started from very basics. Yes, you guys, are you understanding clearly? Topics. Are you understanding clearly? Yes, explaining slowly. Yes, see, I will my way of explaining generally slowly and clearly, neatly. I will explain. Everyone can understand easily here. Everyone can understand easily. Okay. Yeah. So tomorrow, yes, we'll discuss about interpreter, compiler. Next about Java starting. See, guys, don't worry. I'll explain very clearly with spoon feeding. Once enter into coding, very clearly explaining, repeated 2 to 3 times repeatedly, like a spoon feeding and very interesting topics. Okay. Yeah, that's all for today. That's all. Yes, any doubts, guys? Yes, today let us wind up. Yes, we'll continue tomorrow. Yes, we'll continue tomorrow. So thank you, guys. Yes.